Ooh, I'm a little excited. It's been a while that I've given a talk, so let's see how this goes. I know. So NDT and SHM, are they the same? Sometimes they are, sometimes they're not. The physics, there's some physics of some methods that are clearly the same. We cannot control the physics, they're given, but the way we look at the data, interrogate the data, use the sensors, that we can control, and that, from my point of view, makes sort of the difference between NDT and SHM. So here's how I see the world. And this is, again, I'm not wearing my 444 hat. This is my academic hat, I suppose. Sort of the top I guess, level that I see, I would say, I would call non-destructive evaluation. So evaluation being sort of a general term of evaluating something. And then underneath we have NDT, non-destructive testing, which is a more deliberate test. So we test something. And on the other hand, we have structural health monitoring. So we monitor something for longer periods of time. That's sort of what I have been using. Not everybody uses these terms, but that's how I sort of see this world. So if we look a little bit more here on the non-destructive testing side, again, these are more intermittent measurements, few measurements. So we go in, we put sensors, instruments in place, we take a measurement. I look at this as an active process because we control the source. We know pretty much everything about the source itself, the stimulus. We know when we apply it, hopefully, we know what it is, what it looks like. We know where the impact is or the source, and we know where the sensor is. So all these things are known. So in that sense, it's sort of more of an absolute measurement. We determine what is. It's a snapshot in time. Here's an example of a GPR measurement. And in this case, we're rolling this cart across a bridge deck, and we take measurements in small increments, but we always know what the source is, right? It's very controlled. With structural health monitoring, I see it a little bit different. It's more of a passive process, but it's continuous, and it can be short-term, long-term. It could be during a bridge load test, where a truck drives across a bridge, for example, and we put instruments on and we monitor that process to capture deformations, strains, rotations, whatever we want to capture. It's passive in that the stimulus is often not known, especially in long-term monitoring. We really don't know much about what's causing what we're measuring. So it's more passive. It also doesn't give us, for example, what the condition is. So the state of the condition, it gives us a change in the condition. And this is an example down on the outskirts of the Indian River down in Delaware, a bridge that was instrumented with many sensors when it was built. And they have been capturing lots of data, information, strain in the girders, displacement, rotations, accelerations. They also measure wind, so we can obviously measure some of the inputs as well. But again, there's not necessarily a direct connection between the stimulus, not as easily relatable, the stimulus to what we measure. So this is sort of how I see it. Below of this, we have sensors, we have data acquisition, data analysis, evaluation, interpretation of these signals, and so on. That sort of, again, is a block that goes across, just like the top. So this is how I sort of see these two terms. To look at the physics, I said the physics might be the same. So there's actually techniques, and I specifically look at the physics, wave motion and vibrations. And then I look at different techniques here. And some of them I would consider NDT, other ones I would consider SHM. So wave motion, so stuff is moving. We have mass inertia, so things start to move. And if we start at the very lowest level, modal analysis, that could be operational modal analysis or experimental modal analysis, depending on the type. It might be NDT or SHM, but we're talking about really long wavelengths that are the order of the length of the structure itself. So these are standing waves, if you will, not propagating, but standing waves. Those are vibrations. And then as we move down the list, so again, depending on how we do it, we could consider that NDT. If we go and we let a weight fall somewhere on the structure, we initiate vibrations at a known point, I would call it NDT. If we just measure ambient vibrations during traffic, wind events. It's just sitting there, it's vibrating a little bit. I would consider it SHM. And then we have other techniques. And so as we go down, we go from these long, really long wavelengths on the order of length of the structure itself to really short ones that propagate in the structure. So with increasing frequency, decreasing wavelength. And so we have techniques like impulse response that's in the sort of below 1 kilohertz range. We have impact echo that goes a little bit higher. Ultrasound acoustic emission, so a lot of it is above what we can hear. That's why it's called ultrasound. So the first two, impulse response, impact echo, we again have a stimulus that we control, NDT. Ultrasonic velocity can be both in my mind because we can install sensors and we can keep sending pulses. So it's becomes sort of monitoring. Acoustic emission, from the way I see it, clearly a passive technique. We don't usually know what causes the cracking that then results in acoustic emission. Ultrasonic wave fields, that can also be sort of both. But so the physics are given. So depending on how we put the instruments on, how we measure it, how we interrogate it, it can be either NDT or SHM. And so one way that those two techniques could be combined, because I think they're really complementary. So I mean, this one thing is terminology, but so I'm showing here sort of on the y-axis health or condition. And that's one thing we could have an entire separate forum in my mind to discuss what health means or condition means and how we best measure that. So I'd just stay away from that. Could be for the bridge, could be for a member, but you can see with age on the x-axis, we sort of have a brand new member or structure. It starts to age and maybe that goes a little bit down. We could define a threshold where we say, okay, this is a threshold where we want to act. We might have some visual inspection at some point. I'm using the example of a bridge. At some point, we might go in with visual inspection and NDT to really look at what's closely determine what that the state is. If that's below the threshold, then we might install a monitoring system. So we can, from then on, really keep track of changes. And then at some point, when SHM tells us, okay, we have enough deterioration, we might repair it and bring it up to a new, good, better level. As an example, this has gained some track in Germany. Actually, this is the Genstorbrücke in Ulm. This is a post-tensioned bridge that has problems, and they have installed acoustic emission sensors to measure, to detect the wire breaks. So that's I think a very good example where you could go in first with NDT, really characterize what the damage might be, how many wires you might have left, then install an acoustic emission monitoring system. And then anytime you get a wire break, you can start basically counting down how many wires you have left, right? Pretty much. And you can run load rating analyses and determine when you have to do something. So that's a very good example of how these two techniques can be combined. So just some summarizing thoughts. Again, they're complementary in my mind. They should be used that way. We can use them to extend the service life of existing structures. We can use them to reduce uncertainty when we build models. That's something I hear more and more. We have a lot of existing infrastructure and structures. How do we best model them? Well, we need information about the properties, boundary conditions, and so on. NDT and monitoring can help determine these properties. And of course, there's all this digital twin push that's also related to that. Monitoring to see what the condition might be after an extreme event, like an earthquake, what happened. And then finally, this is something I'm working on right now, ultra high performance concrete. So new materials, as an example, how do they behave? In this case, we might want to install sensors from the beginning to sort of learn about new materials, how they perform. And that's all I have.
So let's give Thomas Schumacher another hand for getting us started, huh?